My name is Marissa Peterson, and this is my video demo for Target 1B. We're going to start by converting binary to octal, and with that we have this group of binary numbers, and you can see that we've broken them up into groups of three, and that is so we can read it better. And octal that's how it is converted. Each group is assigned a weight, and with that weight there's 4, 2, and 1. So each of these groups and numbers get multiplied by each of these. So 0 times 4 is 0, 1 times 2 is 2, 0 times 1 is 0. So the ones get multiplied with their weight. So here's a good example for this one. 0 times 4, 1 times 2, and 1 times 1, and they all get added together equal 3, which is this number here. When you do that for each of the groups, this is the number we get, and then that ends up being our octal number, and we know it's octal because of this base 8. Now, to go the other way, from octal to binary, we're given this octal number that I made up, and we know it's octal because it has a base of 8. And again, we have the weights that they're multiplied by. But instead of multiplying, we're going to figure out which ones we need to make 7. So for 7, 4 goes into 7, and then 2, so 4 plus 2, and then that's only 6, so we need 1 more. So 4 plus 2 plus 1, so that will end up being 1, 1, 1. Now for 6, we only need 4 and 2, because 4 plus 2 is 6, so it'll be 1, 1, 0. And then for 2, we only need the 2, so it'll be 0, 1, 0. And those are shown here, so we're getting into those nice groups. And then that becomes this binary number, and we know it's binary because of the base. And then the same goes for this number. So for 3, we only need the 2 and the 1, so we'd have 0, 1, 1. 4 would end up being 1, 0, 0. 5 would end up being 1, 0, 1. And 2 would be 0, 1, 0. Now for the hexadecimal table, these are the hexadecimals on the left, and these are the decimals they convert to on the right. So it only goes up to 9, but then it uses letters, and those are the higher decimal numbers, so we'll keep those in mind. So we're going to go from unsigned binary to hexadecimal. So with this made up binary number, because it has a 2 base, we're going to split them into groups of 4, because hexadecimal, you need groups of 4. And their weights, instead of only going up to the 2 power of 2, we go 1 more, so 2 power of 3. And those end up being 8, 4, 2, and 1. So just like before, you do 0 times 8, 0 times 4, 1 times 2, 0 times 1. So you'd end up with a 2 number there. And then same with this, 0 times 8, 1 times 4, 1 times 2, 0 times 1, and then you add them together for 6, so you'd have a 6. So your answer ends up being like 269 with the base 16. That is the base for hexadecimal. Here's another number, and I didn't point this out on the other one, but we were missing a couple zeros because there wasn't quite enough to make perfect groups of 4. So you have 4 here, 4 here, and then you only have 2 here, so we needed to add a couple zeros. On this one, we have perfect groups, so it matches up really nicely. We have these zeros that are don't need to be added because they're there. And then these numbers end up being these with these multiplied base weights. So we have 2, 5, 11, and 6. So 11 doesn't compute nicely to it does compute nicely to hexadecimal, and the 11 turns into a B. So then your hexadecimal number would be 25B6. Now going the other way around from hexadecimal to binary, we have the hexadecimals that I made up. We're going to go along through each of them. And I put the little table over here for the letters on the right. Alright, so here's the bases, the weights again. So 5, to get 5, 8's too big, so that would end up being a 0. 4 goes into 5, and then we need one more, because 5 minus 4 is 1, so we would get a 1 over here. So we'd have 0, 1, 0, 1. For C, if we remember over from our table, it's 12. So 8 plus 4 is 12. So we'd have 1 plus 1, 0, or 1, 1, 0, 0. And then 3, we would only need the 2 and the 1, so it'd be 0, 0, 1, 1. And then for 1, we only need the 1. And that comes out over here. Now for this one, D, F, 4, 7, we have 2 letters. So our D is 13. So 8 plus 4 is 12, but we don't need 2 more, we only need 1 more, so we'd have the 1. So it'd be 1, 1, 0, 1 for D. And then F is the highest, so everything gets a 1. So it'd be 1, 1, 1, 1. And then for 4, we only need the 4, so 0, 1, 0, 0. And for 7, we need the 4 plus 2 plus 1 to equal 7, so we need 0, 1, 1, 1. And here's those down here. I hope you enjoyed my presentation. Have a good day.